Welcome to CS50's Prep and Practice for Technical Interviews. So this is the second time we've done this event, and it was born of what we felt was a problem even as far back as when I was an undergraduate, whereby there's all these tech companies coming to campus, and there's this momentum on campus certainly to interview and to interview early. And at least if you're anything like me, my first experience was really just kind of being thrown into the deep end, whereby I knew I needed to be interviewed, and I generally heard I should know how to explain like linked lists and things in these interviews, but I didn't really have an opportunity or really a framework in which to practice and to prepare for these things. And in fact, the one tidbit or advice or anti-advice I'll offer is the one mistake I remember making, and I offered this up last year, when I was asked during a Microsoft interview back in my day, like, what is your favorite language? I decided during this interview as like a sophomore or junior to try to impress the person, and I said assembly language is my favorite language, at which point he kind of reasonably proceeded to ask me a question in assembly language to implement, which was a horrible, horrible experience. And so choose something like pseudocode if ever asked that question perhaps, or some language that might scare you a bit less. But allow me to actually turn things over to some experts who have worked in industry more recently, certainly, than I, including CS50's own Maria.
Thank you. Hi, everybody. So my name is Maria. I'm CS50's head teaching fellow, and for the past 2 summers, I've been a software engineering intern at Facebook, and it was an awesome experience, but my interview experience was not always very smooth. I remember when I first started hearing about technical interviews, they all sounded like very daunting and very scary. So going into my first technical interview, I had like barely cracked open cracking the coding interview. I had like done 0 practice interviews because like I was kind of terrified of them. So going in, I got asked like a question about like linked lists and partitioning linked lists, and I came up with like a super like grotesque solution with like hash tables, and the interviewer proceeded to ask me to like implement something simpler, and I asked for about like 15 more minutes silently writing on my paper, and at one point he was like, okay, I think we're done here. So I'm so glad you all are here and are not repeating the same mistakes that I did and are actually practicing. And with that, I'm going to turn it over to Tommy, and thank you all for being here.
Hi, everybody. So my name is Tommy. I graduated back in 2013, also was head teaching fellow for CS50, and I've been working at Quora for around 4 years now. And with me is Jelle.
Yeah, I also graduated from Harvard in 2013, was a teaching fellow at CS50. I've worked at Quora for 4 years, and basically the same as Tommy.
So as David and Maria mentioned, the goal for today is really just to go over a crash course on interviewing. So everything from before the interview, how to prepare, the interview itself, after the interview. We really just want to give you a full picture of everything that's going to happen during an interview and give you lots of tips and tricks to help you be more successful. I can add on to this chain of interview horror stories. My first technical interview I remember was at Facebook. I was taking CS51 at the time. I don't know if this is still true, but at the time, CS51 used this like bonkers language called OCaml, and since I was, okay, good. And so I went to this interview, and there's a super simple question that just boiled down to like traverse a binary tree, and I was like, okay, well, I know OCaml. I thought I knew OCaml, so I'll just do it in OCaml. Just horrible, terrible, in 45 minutes, got nowhere. Very clear that I wasn't going any farther. And then I distinctly remember having to take the elevator down with my interviewer, because I was the last interviewer of the day, just sort of like staring at the ground, knowing how awkward that was. So my goal today is to help you avoid such instances by giving you lots of tips on interviewing. So this is our agenda for today, basically from end to end, the whole interview process. So I'm going to focus on before the interview. Then we're going to hear from Jelle about how to prepare for the interview. We're going to do some mock interviews with me and Jelle, showing you what's good, what's not so good, so an actual interview itself. Finally, what to do after the interview. And then lastly, we're going to have lots of time for Q&A. We found that often people love to ask questions about their own personal experience or something they're not sure about. So we'll leave lots of time at the end for Q&A. And then Jelle and I are also going to hang out here if you just want to talk one-on-one with us about interviewing or anything like that. So that's a rough picture of what we're going to be doing today. So let's start with before the interview. So the first thing you need to do before interviewing is pick where you're going to interview. And so I have 5 questions here to ask yourself when you're choosing a company. You know, something you want to probably avoid is interviewing at every single company there is. There are lots of companies, as it turns out, in tech. Interviewing at all of them is not only going to waste your time, it's going to waste the company's time. So, you know, while you do want to cast a broad net in things you're interested in, you do also want to only interview at companies you realistically see yourself working at. So here are 5 questions that I think are good questions to ask yourself to figure that out. So for the first one, ask yourself what you're looking to get out of an internship or full-time job. I've listed a few things here, but something I want to emphasize is that everybody is really different. Some person might be looking to go somewhere and have a ton of impact and work at this small company and be responsible for end-to-end features and really have a huge impact on the product. Someone else might say, it's my first internship, what I want to optimize for is learning, and I want to go to a larger company where I can just learn from a bunch of senior folks, and I might have less impact, but I'm going to learn a lot more. Other people might say, I'm not sure if I want to live on the West Coast or the East Coast, so what I'm looking for is I want to experience what it's like to live in New York City or experience what it's like to live in San Francisco, and that's sort of one major factor. So everyone is different, and every internship you do might have a different answer to these questions. But these are, think about this first. And it's something, by the way, that your interviewer is probably going to ask you about as well. What are you looking to get out of this internship? What are you trying to optimize for? So think about this in advance, and then you'll have an answer for that question as well. So next, would you be excited every day to go work on the product? The way internships and jobs generally work is you get up every day at some time, often in the morning, and you spend a substantial amount of your time working on something. So if you don't really like the thing you're working on, you're not going to have a great internship or a full-time job, and you're probably going to get less out of whatever you're trying to optimize for. So first thing to do is when you're applying to different companies, use their product if you can. So, many companies have products that are targeted at consumers and you can go and use. Other companies are more enterprise focused and might be harder to use, but it's still pretty easy to get a flavor for exactly what the company is trying to achieve. So that gets at what the company's mission is. Companies often advertise their mission. They talk about what they're trying to do, their vision for what they can do to the world and how they can improve it. So read about that and think about, is this mission something that you're excited about? And if it is, then that's probably somewhere you want to look. And if it's not, actually, really think about, is this worth interviewing at this place? Because I'm not excited about the mission, and I'm also not excited about the product, which is sort of the implementation of the mission. So third, would you be excited to get up every day and work with the people? So this is something that's pretty easy to undervalue. It's easy to think about just the mission and just the product, but that's really only one dimension. At the end of the day, companies are made up of people. And the people that you're working with are going to have a really large impact on your experience in an internship or at that company. So during your interview process, you'll probably get to meet with a variety of different people from that company. And as you're doing that and having those conversations, you also want to be thinking to yourself, are these the type of people that I want to be working at? Did I enjoy my conversations with these people? Did it seem like we valued the same things? Really think about that. And also, after the interview process, once you have an offer, you also want to use that as an opportunity to talk to more people at the company. So once a company gives you an offer, whether it be for an internship or a full-time position, they want you there. If they didn't want you there, they wouldn't have given you an offer. And so something that companies are going to try to do is convince you to work there. It's highly likely that people have multiple offers from different companies, whether it be internship or full-time. And so companies are incentivized to try to convince you to join theirs, which means that they'll often be very, very willing to set you up with conversations. Some companies call them reverse interviews. Some companies less discreetly call them cell chats. Where you'll be set up with different people at the company, you can ask them questions like, what is it that you're working on, or hear more personal experiences from engineers or data scientists or whoever you're interested in talking to. So many times after a company gives you an offer, they will say, would you like to talk to some more people, do some reverse interviews? Definitely take them up on that. It's a great opportunity to learn not only more about the company, but also about the people you'd be working with. And if a company does not offer, you should ask yourself. It's pretty unlikely that a company will say, nope, that's it, no more conversations with us, like decide, take it or leave it, your offer. If the company does do that, reconsider. So ask your recruiter, or whoever your point of contact is at that company, if they'd be willing to set up some more conversations, and they probably will. This is a great way to learn more about the company and the people working there. So fourth, do the things that you value align with the things that a company values? So especially in Silicon Valley, kind of Bay Area companies, they'll often advertise some set of values. It's usually between 3 to 10 statements about what the company values. You can generally think of a value as things that company values more than other companies do. So for example, something like don't kill people is not a good value because every company probably values that the same, hopefully. But instead, values are sort of an articulation of what sets this company apart from the other many companies in the same space. So to make this a little concrete, these are Quora's values. I'll give you a quick flavor for what this means. So our first value is mission first. So this means something we value is really putting the company and teams ahead of your own personal interests. So always thinking about how can you make sure that the company is doing the right thing more than you're worried about your own personal outcomes, things like that. Next one is drive. So this is about pushing the envelope, driving things forward, taking initiative, things like that. Agility. So we really value the ability to change and turn. especially in, our product is constantly changing, market's constantly changing, and so if it's too hard for us to pivot or dramatically change how we do something, that's going to put us at a disadvantage. The fourth one is awareness. So you can think about this of awareness of data and metrics and trends happening in the industry and trends happening in the world, and how you can translate those data and quantitative observations into what you're actually working on in the product. And then finally is pragmatism. So we really value rational thinking, being pragmatic, not being overly ideological or principled, but sort of doing what makes sense in every individual situation. So those are Quora's values. Every company has their own. They're pretty easy to find most of the time on a company's site. So check them out, and also think about what are the things that you value. And if the things that you value line up with the things a company values, that's good signal that that could be a good fit. So the last one, sort of the easiest one to think about, is how big is the company? So this is a matrix that was made by one of the founders of Asana that I think breaks this down really well, so I'm just going to use it. You can roughly think of companies' size as divided into 3 buckets. You have the really small company. This is the small startup, could be Series A, even before that, probably capped at around 50 people. Then you have the mid-sized company. So this is a company that's probably raised a few rounds of funding, has somewhere between 50 and 500 people. So this happens to be where Quora is. Then finally, there's the large company. So this is the very often a public company. This is something like a Google or a Facebook, or over 500 people, sort of large. And so then there's a bunch of dimensions here that you can think about. I won't just read the thing to you, but I'll just go into one of them, which I think is important, is autonomy. So I think this is one that really sets companies apart. So at a really small company, you have extremely high autonomy. When you get there your first day, you might not even have a desk assembled, and your first task might be like, go buy a desk at IKEA and assemble it. Really, you're doing whatever needs to be done. If there's some business relationship you need to develop, you might go out and do that, even if you're an engineer, or you need to design something, even if you're not a designer, you might have to write the CSS and things like that. So super high autonomy. At a mid-sized company, you have less autonomy than that, and that there are probably teams. Each of those teams probably has goals. But what you don't have is a really concrete to-do list. So you might be tasked with, we want to move this speed metric down by 10%. Nobody knows how to do that. It's up to you to figure out how to achieve that high-level mandate. But it's more so than just make the product better. And lastly, at a large company, that's when you get to see much more crisp directions. You might have a really clear set of tasks defined. You might have a project with a really clear goal and outcomes, and also how to get there. And so you just have relatively less autonomy. And again, something I want to emphasize is no column is better than the others. Like I said before, everyone is looking for something different. If you're on Twitter or just talking to your friends, you might find people who are like, oh, never work at a large company, or never work at a small company, or you'll see every opinion. But none is better than the other. Everybody is different. Every internship might be optimizing for different things. And so think about where, which cell you fall in for each of these rows, and that can help you decide what size company you want to be at. OK, so now that you've decided on a company, I just want to do a quick brief take on resumes. So it turns out that resumes are not that important. They tend to be overvalued, and people tend to spend much more time on resumes than they actually need to. To illustrate this, how much time do you think a recruiter or hiring manager spends reading your resume? Just shout out numbers. A minute, 2 minutes, 5 minutes? 60 seconds. Yeah, I'm going to give a really, really, really conservative 30 seconds as an absolute maximum amount of time I am going to spend reading your resume. So as you're developing your resume, keep that in mind. Someone is not going to spend more than this amount of time reading it. So to that end, I have 10 very simple resume rules. If you follow these 10 rules, you probably will not mess up your resume. So I'll go through each of them. First, your resume should be 1 page. There are absolutely 0 exceptions to this rule. I've seen the resume of the person who invented the Python programming language. It's a page. If you did more than he did, then maybe you get more than a page, but I don't think you did, so keep your resume to 1 page. Second, make it really easy to skim. As I said, I'm spending 30 seconds on this, so if you make it so that I have to search around and your resume is hard for me to read, I'm just not going to. I have another stack of like 1,000 more resumes I could be reading. So make it really, really easy for the person who's spending a small amount of time reading your resume to skim it and get the most important information. To that end, Third, your contact information is the most important piece of information on your resume. The whole point of giving your resume to somebody is so they can say, hey, this person looks like someone I'd be interested in moving forward with. Let me contact them and move forward with them. So if it's too hard to find your contact information, you're sort of missing the point of a resume. So make it really, really easy to find your contact information, an email, a phone number, address. We don't really need that. We're not going to mail you an invitation to interview. So just email, phone number, that's it. Make that really easy to find. Fourth, you want to highlight specific accomplishments. So if you have an internship and you did something like I shipped this feature and it moved this metric by N%, if you can say that, put that on your resume and be as specific as you can. Some companies will have NDAs and they won't allow you to disclose changes in metrics and things like that. And that's okay if you can't be that specific, but be as specific as you can. That's a lot better than just said worked on X team or worked as an engineer. It's not specific. I have no idea what you really did. But if you can highlight some specific, impressive sounding accomplishment, that's going to be really good. Finally, include interesting personal projects. So if you do, go to hackathons, or you've worked on some side project on the side, like some API or some fun little script you wrote, include that in your resume. It helps set you apart from a lot of other people who might have similar experiences. Something I don't recommend is putting course final projects that are sort of the same for everybody that took that course. So often we'll go to universities and we'll see like 100 people say like, oh yeah, I made multiplayer Pong. And it turns out that was just like a final project for some CS class. And that was sort of like a waste of space on your resume. So if you'd made something sort of novel and on your own, I think that's worth including. But if you just sort of did like a course assignment, basically, that's probably not worth including as a personal project. So those are the 5 do's. And now for the 5 don'ts. This is my biggest pet peeve on resumes, is when people put charts or ratings next to skills. There's absolutely no reason to do that. Please do not do that. You'll often see somebody say, they're like a 5 stars in JavaScript, and I just sort of sit there and say, what does that mean? Like, is the inventor of JavaScript a 5 stars in JavaScript? If so, then you're probably not. It just doesn't make any sense. It doesn't add any value. Second, do not include an objective. You'll often see at the top of a resume something like an objective or what you're looking for. If you're giving me a resume, I sort of know that you're seeking a challenging position in the field of software engineering where you can showcase your unique. I know that. Like, don't like waste the space by putting it at the top of your resume. We also know that references are available on request. I see this oddly at the bottom of a lot of resumes. Again, it's just a total waste of space. It's not like if I don't see that line, I'm not going to try to get a reference if I want one. It offers no value. Second to last, if you don't have a professional-looking email address, just make one. Gmail addresses are pretty easy to create nowadays. So if you're still using, your high school instant messaging name or something like that, just create, a simple first initial, last name, something at Gmail. If you have your Harvard address, use that. It's great. Don't use like a silly email address. It's just sort of like it gives your hiring manager or recruiter like a reason not to like you. So don't do that. And last, include relevant links. So your GitHub, your LinkedIn, all that's really good. Some people include their like personal Facebook or personal Twitter. If you want to, go for it. It doesn't really add a lot of value. If you give me like a Twitter account where you're doing a bunch of like unprofessional things, I'm not thrilled. So those are the 10 resume rules. If you follow those, you will have a good enough resume. And again, good enough is all you need because I'm not going to spend that much time on it. So to that end, so here's an example resume. This is not a real resume. I did a Google image search for resume, and this is what I got. So what is good and bad about this resume?
There's the ratings at the bottom.
Yeah, so here we go. Ratings at the bottom, totally unnecessary. So this person manages to be a 5 stars in organization and a 5 stars in time management, but then only comes out on 3 stars in a team player. I don't even know what that means, but I'm not really excited to hire a 3-star team player, so I'm not thrilled about this resume. Yep, what else? Good or bad?
Easy to skim.
Yeah, so this is pretty easy to skim. So you can see up here, using bold for company and role. It's really easy to see, okay, this person worked at these 3 companies and did these 3 things. So yeah, definitely easy to skim. What else?
Really easy, really readable, contact info.
Yeah, contact information was easy to find. Name at the top left, and then these nice little icons. Again, I don't know. One, I don't know how he snagged the Twitter username JS, but 2, I don't think you need all of this stuff, but it was really easy to find his email, which is all that I'm looking for. What else?
That intro. That is an intro.
Yes, exactly. That whole thing at the top, there's no way I'm reading that. Absolutely no chance I'm going to read what that says. That's just a waste of space. He could have could have taken that space, used it to talk more about his experience as a director at something, rather than putting something at the top that I didn't read. So it's a waste of space. You only get one page, so use it carefully. How about one more? Yeah, the picture, totally unnecessary. This is sort of a thing you include if you're like an actor or in that industry. We're probably not. So again, no reason to include that. It's just a waste of space. You could have taken that space and you could have, again, moved everything over to the left and had more space for things that actually matter. So that's one. Here's another one. Multiple pages, the easiest rule not to break. This is multiple pages. Do not do that. One page, no exceptions. What else? Yeah, super hard to skim. So this is sort of what I mean when I say it's hard to skim. That's like super high information density. Some stuff is right aligned, some stuff is left aligned. You don't have to be like a world-class designer to understand that this is really hard to skim. What else?
There's some charts again.
Yeah, again with the charts. I didn't even have to like look for this. They're just everywhere. Super not helpful. This person breaks down their analytical skills and teamwork skills into a pie chart. I kind of question the resolution of this, but again, really no need to do that. I do not care about any of this information. Let's go one more. Good or bad? So I think the last one, contact information was pretty easy to find. It's right at the top. It's colorful. That was easy for me to find. It's also repeated down here at the bottom just in case. So I think that's sort of the redeeming quality of this resume, is that I can contact this person if I want to, though I probably don't. OK, so that's everything on resumes. Not going to talk any more about resumes because, again, they're not super important in the grand scheme of things. So next, I'm going to walk through a few different types of interviews that you'll probably encounter in any technical loop. So you might be engineering, might be data science, might even be design, but these are a rough breakdown of the types of interviews that you're going to see. Unfortunately, your interviewer will probably not say this is going to be X type of interview, but you can sort of tell from the outset what it's going to be. So before that, just some quick logistics. So start interviewing as early as you can. The common time to interview for interns and full-time is in the late summer, early fall. Luckily, this is now, so you're not behind the curve if you haven't started interviewing yet. But if you haven't, would start soon. Some students will even interview for summer I+1 during summer I. So they're out in an internship in the Bay Area in summer 2017, and before they even go back to school, they have an internship landed for summer 2018. This sounds crazy. It's a thing that happens. If you know you're going to be in the same place, it's kind of a nice way to save yourself on flights if you're not interested in the frequent flyer miles. So you can do that if you want, but it's just be aware that it's something that happens. You should also plan interviewing into your semester. If you know you're going to be interviewing for full-time roles and you expect a lot of interviewing, it's a bad time to take 5 classes or something like that. Think of interviewing and recruiting as a class or an extracurricular or whatever helps you plan. But think about that as you're picking your classes and figuring out where you're going to be doing for a semester. It just takes a lot of time. There's no way around it. It just takes a lot of time for everybody, and just expect it to take a lot of time for you. Another thing to do is look for programs that are targeted at your year. In particular, if you're a freshman or a sophomore and you don't have that much programming experience, but you're interested in getting an internship, that's great, and that's totally OK. And there are many companies who have programs designed specifically for that. So at Google, they have a program called the Engineering Practicum. Microsoft has an Explorer program. Facebook has Facebook University. A lot of these larger companies have programs that are specifically targeted at people who don't yet have a lot of programming experience. So if that's you, look for those programs. You're going to find a lot more success in those interview loops than you are when you're in roles that are targeted at people who have 2 or 3 internships under their belt already. So just think about where you fall in that experience level and look for those types of programs. When in doubt, ask your recruiter. Say, what roles are right for me? What programs should I be looking at if I'm somebody who's taken 2 CS classes and has never done an internship before? By no means do you think, don't eliminate yourself or think I can't get an internship anywhere, because everybody has to start somewhere. And there do exist these programs that are targeted at you if you fall into those buckets. So think about that. So this is sort of like what the whole process is going to look like. So some companies might start with some sort of online coding challenge, where it might be, here's a problem, and you're supposed to write the solution. Maybe you can run it, maybe you can't. Expect that to take around 30 minutes. Then after that, then nearly every company will have some sort of technical phone screen. So this is sort of what we'll be taking a look at. But this will be a 45 to 60-minute technical conversation with an engineer, and we're going to deep dive into what this actually means. And then finally, if that goes well, then most companies will invite you on site. And so here's where you'll meet with a variety of people from the company, usually around 3 to 5, and expect that to be around 45 minutes to 60 minutes each. So if you're an engineering role, also be prepared to speak with people from outside of engineering, particularly at smaller companies where it's more likely you'll be working with people outside of engineering if you're an engineer. So you might meet with people from the design team, the PM team, user operations team. Sort of depends on the company and the role, but just don't be surprised if you see someone walk in the room that's not the role that you're interviewing for. OK, so here are the 5 types of interviews that you will probably encounter, and I'm going to walk through each of them. So the first one is the most common, which is the algorithms interview. And this is the one that we're going to go into much more detail on today because it is the most common one. But just at a high level, an algorithms interview is an interview where the problem is more about getting to the solution than actually writing the code for it. So often the actual code for this is really straightforward. It might only be 5 to 10 lines of code. But getting there and getting to the solution is the hard part. And so often if you're doing an interview problem and you find that the solution is like 5 to 10 lines, it doesn't mean you're wrong. It probably just means that this is an algorithms type problem. But the interviewer doesn't care so much about the code that you actually write. It's more about how did they reason about the problem and how did they get to that high-level solution. So when you're approaching an algorithms problem, try to optimize for both space and time complexity. It's OK to start with a naive solution and then optimize later. It's a much better outcome for an interview if you come out with something rather than coming out with nothing. So if you're given a hard algorithms problem, it's much better to have an unoptimized solution and you've made some progress and you have something down and the interviewer can see your thought process and code. That's a lot better outcome than you just sort of sitting at a computer for 45 minutes and ending with a blank slate because you're trying to get the super optimized solution first. So it's often a pretty good technique to start with something you know works, might be exponential in time or space or something, and then optimize that later. And another tip with this, if the solution seems way too complicated, then it probably is, and there probably is a simpler way to do it. So as you're writing code, if you find yourself writing your 15th edge case, think to yourself, this seems overly complicated. I bet there's a better way to do it. A lot of these interview questions are not designed to have you come up with like 15 different edge cases. And so if that's the approach that you're taking, there probably is a better solution to a problem. So it can be good to just take a step back and try to start from scratch or rethink your solution if you find that it's just getting hugely overly complex. And again, we're going to go into much more detail on this one later because this is probably the most common interview type. So what are some examples of sort of classes of algorithms problems? Just shout them out. Yeah, dynamic programming is a huge one. That's one you'll find. What else? Well, that's why we're here. So other ones, so strings is super common. So things like reverse a string, is this string a palindrome? Whatever, so things in the strings, stuff with recursion, so problems explicitly designed to have a recursive solution, so being able to write recursive code pretty easily. Dynamic programming, which we mentioned, which is sort of optimizing those types of problems. Things with graphs and trees, so being able to traverse a graph, traverse a tree, reason about the size of a graph, things like that. And finally, this last category, which is basically just math, where things that these are problems where they might just have a closed form solution. And if you're that sort of mathy type that's good at that, these problems exist where there'll often be some sort of quadratic or exponential recursive solution, or there's just this constant time closed form solution if you know math. And so often you can write the naive solution. If you don't get the optimized one, that's OK. But this is just sort of another category that exists. So here are your tools for solving basically every type of algorithms problems. So these are things that you should basically know down cold going into an interview. If you're going into an interview and you already know what a hash table is and how to implement it in a language, you're just going to free up those mental cycles to actually think about the problem. So here are some tools that you should just have in your toolbox. So arrays and linked lists, knowing the differences between them, knowing when it's appropriate to use an array, when it's appropriate to use a linked list, how in the language of your choice you would implement a linked list. Hash tables are super common, being aware of what a hash table does, when it's appropriate to use, the complexity of different operations. Shortest path algorithms. Many problems that involve graphs or trees can just be reduced down to a shortest path problem. In fact, many problems out there are actually just a shortest path problem. So being familiar with algorithms like breadth first search, A*, if you want to impress your interviewer, that's helpful to have. For string problems, just knowing the built-in string methods in your language. So knowing, are strings mutable? How do I iterate through a string? How do I reverse a string? How do I lowercase a letter? Things like that, just being aware of them and having them in your toolbox. You don't have to think about it during the interview. And finally, memoization. In many problems, there's some exponential solution, and to get it down to the optimal solution, all you do is memoize it or cache it. So being able to do that really quickly and knowing if there are tools in your language to just do this fast, being aware of those, you can do that on the fly. So that's everything on algorithms. So I'll go more quickly through these other four since they're a little less common. So sort of the opposite of the algorithms problem is the coding problem. And so this is where the problem is simple. You often will see the solution pretty immediately, but it's the implementation that's more complex. It might require you to write a lot of code, think about decomposing your code into different methods, refactoring code, coming up with clean variable names, stuff like that. So here, the best advice I can give you is to decompose the problem as much as you can. Here in this coding problem, if you find you're writing a lot of code, the interviewer probably cares a lot about the quality of that code. So when we say code quality, we mean things like your variable names, your style, the design of the code, sort of all the things that you're graded on in CS50, not coincidentally. So here, you want to make sure that you're creating helper functions appropriately, you're factoring out code, you're not repeating yourself, and you're always asking yourself this same question of how can I make the code even simpler? How can I reduce how much code is written? How can I make this easier to read? And the more you're asking yourself this question and proactively making these changes, the better you're going to do in this type of interview. For example, if someone writes this long, messy piece of code, and then they say, OK, hey, there's some repetition here, I'm going to go factor that out, that's a lot better than me looking at that and saying, hey, I think you could factor this out. The more proactive you can be about anticipating your interviewer's concerns or problems that they might see, the better you're going to do in these interviews. And here, familiarity with the language helps a lot. Basically, the more code you're writing, the more familiar you are with that language, the easier it's going to be for you to write a lot of code. Next up is the practical interview. So the gist of the practical interview is that given some large existing code base, your job is to make some changes to it. So for example, we might have this large code base, it's many files, it's tens of thousands of lines, and there's some bug somewhere. And your job in this interview is to go in and fix that bug, which is very, very different than implementing something from scratch. So the skills that we're looking for here are your ability to navigate a code base, your ability to reason about how different pieces of a system fit together, your ability to read and understand code, and not so much your ability to write code, since those are two sort of different skill sets. And so best advice for this interview is really take that time to really understand the different parts of the system. Often, fixing the bug might be a one-line change or a one-character change, but the hard part is finding it and understanding the system well enough to reason about where something might be going wrong with it. So often in this type of interview, where you're given this huge code base, you're probably going to spend more time reading than you are writing, which feels sort of weird for a technical interview, but that's just sort of how these go. So in order to do well in these, I definitely advise you to be familiar with some sort of development environment. So if you're like writing Java, being familiar with Eclipse. If you write iOS apps, being familiar with Xcode, or just being familiar with like a text editor in a Unix environment. Really, whatever you want, just pick something and become familiar with it. Sort of if you're asked to write something from scratch, or you're given a huge code base, and they just say, use whatever tools you want. Have some tools in mind and be comfortable with a text editor or an IDE or something, so that you can jump right into this. So as an example, let's say you're given some large system, a pretty effective strategy would be to use breakpoints. And so, OK, make sure your environment. In your environment, you know how you would create a breakpoint. Another good tip for these is to utilize the call stack as a mechanism for finding what's going on. So often, the first thing I do when I'm jumping into a large code base in an interview or not is I'll just pick somewhere and I'll just divide by 0, since that throws an exception, which gets me a stack trace, which then I can now see all the different things that were called in order to get me to this piece in the code base. So this is a pretty cheap and dirty way to understand the system pretty quickly. So you might be in some function and you're wondering, OK, what called this function? How did I even get here? Just throw an exception and look at the stack trace and use the stack trace as sort of your map of the code base and as a way to understand it. That's going to be a lot easier than trying to manually open files and manually look at what's calling what. I mean, that'll work. But often, this is sort of the call stack is doing this for you. So utilize that as much as you can. Get to the point where looking at a call stack isn't scary or daunting. You're sort of used to it. You know what it looks like in your language of choice. And you're able to reason about it and jump around quickly. So that's it for the practicals. So next is systems design. So this one is a little less common for interns and new grads. and that it's usually more targeted at someone who's a little more experienced and has experience designing large-scale systems or products or things like that. But it still might come up, again, particularly at these smaller companies where everyone is going to have to be doing these things. So just be prepared for it. So systems design problems fall into two categories, technical systems design and product systems design. So designing a technical system might be something like, how would you architect the Gmail app? And then a product design question might be something like, what feature is missing from Gmail? So I think these would probably be two good questions if you're interviewing for Gmail. If you're interviewing for, let's say, Quora, hypothetically, a question might be like, what feature is missing from Quora? And so the more that you are using the product and understanding the company, the better you can do on these types of questions if you're asked them. So how to approach a systems design problem. So the first thing you want to do is understand all of the constraints of the system. So those two problems I just gave, how would you architect the Gmail app, that's super, super, super open-ended. And so your first goal should be to narrow down this humongous problem space into something that's a lot more tractable and that you can realistically have a conversation about in a 45 to 60-minute interview. So as an example, how would you architect the Gmail app? First question, am I concerned with the client or just the server or both? And you're going to say, oh yeah, don't worry about the server, assume that exists, just focus on the client. You just cut down a humongous portion of that open-ended problem. And so keep going. Do I have to worry about low latency connections, or can I assume that it's fine? Do I have to worry about older devices and memory or processor constraints? Your interviewer is just going to say yes or no, and you're going to have a much more well-defined problem. So that should be the first thing you do with any problem, not only just system design, but any problem that you see is like really open-ended. It's that way on purpose, and the interviewer is looking for you to cut down that large problem into a much smaller space. So next, be aware of any assumptions you're making. So when you assume something like, OK, I'm going to assume that there's some server that has this API call, just state that out loud. If you're making assumptions that the interviewer is not aware of, then it's going to be harder for the two of you to be on the same page. And you might make some assumption that's not valid. So rather than saying, asking the interviewer, should I worry about the client or the server, if you just assume you have to think about both, and then you spend 10 minutes talking about a server only for the interviewer to say, actually, you don't need to worry about the server at all, that's a pretty bad outcome. And so the more that you can be vocal about what assumptions you're making and things that you're thinking about, the better you're going to do on these types of problems. So next, think about the consequence of every decision you make. So often in software design, everything is about trade-offs. There's many times where picking a certain algorithm or data structure or something has a bunch of benefits, but it also has a bunch of cons as well. And so think about that and vocalize both of them. So think to yourself, OK, and say out loud, OK, if I pick a hash table for here, that's going to make lookup really easy, but it has this other constraint where it might be more memory intensive than some other data structure. And vocalize that and think about that out loud, rather than just sort of picking something and assuming it works. Pick something and then think about and vocalize the consequences of that decision, and then use that as a mechanism for sort of weighing different trade-offs and thinking about things. Again, it's very rare that there's one absolutely best answer that has all pros and no cons. So think about them both when you make any decision in your design. So related to that, something else you want to do, again, not just in system design, but in interviewing generally, is challenge your own ideas. As soon as you propose something and say, I think we should use an HTTP API that returns JSON, try to break it. Immediately say, OK, well, what's the problem with that? What is that going to prevent us from doing? Is that going to be slow? Is that going to be incompatible with some other thing? Challenge your own ideas, because if you don't, the interviewer is just going to do that for you. As an interviewer giving a systems design problem, that's sort of my goal in the whole thing, is to try to break every system that someone comes up with. So the more that you're proactively trying to break your own system, that's going to show to me that you're thinking about the consequences of your choices, that you're able to reason through a system without me having to prod you manually. So again, just be proactive and vocalize consequences and possible trade-offs you're making with the system. And finally, consider how future-proof your design is. So there's sort of two elements of scalability to think about. One is this thing going to break with a ton more users? And two, is this thing going to break if a ton more people start developing on it? Maybe you're using you suggest implementing something on your own instead of using some third-party library, but maybe that third-party library is much better for scalability in that it's been battle-tested, or more developers can pick up on that easily because there has all this documentation and things online. So things like that. Think about when you're thinking about how your system is going to break, think about those two dimensions of scalability. More people working on it, and then more people using it. So finally, the last type of interview that you'll often find in nearly every on-site loop, you probably won't find this in a phone interview, is the culture interview. And again, this one is really, really important. We've had many candidates who we did algorithms interviews, we did coding interviews, we did practical, and they knocked them all out of the park. And then we came down to the culture interview. We just found that they weren't a great fit for the company. It doesn't matter how you do on all the technical things. If you're not a good fit with the company's culture, we're not going to give you an offer. So many times this whole interview can be sort of a deal breaker type interview. And so take it seriously. It's really easy to just focus on the technical stuff and not think at all about this sort of like culture fit type interview, the conversation you'll probably have with a hiring manager or recruiter. It's sort of easy to just like forget about this or take it for granted, when in reality, this can often stop an entire offer from going through. So what is a culture interview? So this is going to be a non-technical conversation. And sort of the goal of this interviewer, for me as an interviewer, is to figure out if the things that you value align with the things that the company values. So again, this sort of goes back to what I was talking about before about each company's values. But really, the interviewer's goal is to find out if you're a good fit for that company. And we're going to do that in two ways. The first way is looking back, and the second way is looking forward. So I'll go into each. So when I say looking back, that means I'm going to ask you questions about your past internships, your past projects, things like that. Particularly if you give me a resume that say you worked at Facebook last summer, I'm going to ask you what you did at Facebook last summer. And not just what you did, but more specifically, I'm looking for people who are introspective and think about what they took away from that experience, what went well, what didn't go well, and what they took away from that experience. The more that you think about that up front and have these stories and you're ready to talk about them, again, you're just going to do fine in the culture interview. Having these things down cold is just as important as having down cold how you create an array in the language of your choice. So those are things I'm going to ask you. With your project, what went well, what didn't go well, what were some of the hardest challenges you faced, and if you faced a challenge, how did you overcome them, and what would you have done differently with the benefit of hindsight? All these sort of get at, after you've gone through an experience, what are you taking away from it? Are you learning? Are you growing? We're looking at people who have like this sort of growth mindset, always looking to improve, and the way that you can demonstrate that is by thinking critically about this kind of thing. So that's looking back. And looking forward is more questions about what you're looking to do out of this position. So for example, a pretty simple one that you'll get everywhere is, why this company? There's hundreds of companies in this space doing the same thing. Why us? If you do not have a good answer for this question, that's a problem, because we're looking for people to work at a company who are excited about that and have a reason for applying. Not only why this company, but what do you want to work on? Do you like back-end systems and algorithms? Are you looking for machine learning? Are you more of a front-end person who likes developing features? Everybody has different preferences. There's no right answer to this question. But the more that you think about it and can clearly articulate an answer to this, the better that the interviewer is going to be able to match you with a team or a project or something where you're going to have a lot of impact. Also, what are your short-term and long-term career goals? So again, what are you looking to get out of this internship? What are your goals for the summer? Or where do you want to be in your career in 5 years? Are you someone who wants to stay in engineering, try to get into management? Are you someone who might go back to grad school someday? Just talking about that and thinking about it. And finally, what are the important parts of a culture to you? The interviewer probably knows the company's culture pretty well. And so by getting a flavor for what you're looking for out of a culture, again, we can figure out if you're a match. So the way to prepare for this interview is just take some time to reflect. You don't need a lot of time, but just think about your past summer. Think about what you're looking for in an interview. For this looking forward type question, I think a good question to ask yourself is, what does your ideal day look like? Many interviewers will actually just ask you this question verbatim. But what does your ideal look like? Are you working with people most of the time? Are you working on this hard back-end problem? What kinds of things are you doing versus not doing? Avoid being overly negative about any past experiences. We've all been there. We've had internship experiences that weren't great. Maybe we had a bad mentor who wasn't there. Maybe we just had a manager who just wasn't a good manager. But don't be overly negative in an interview. If I'm an interviewer and someone's telling me about how terrible their summer last was at some company and they had an awful manager, what I'm thinking to myself in the back of my head is, okay, so are they going to go off and say the same thing about my company when they're talking to their friends in a year? If the answer is yes, that's not great, because suddenly you're going to make this company look bad, and we don't want that type of person working here. So avoid being overly negative, because it reflects poorly on the company, and they don't want that type of person. So finally, many companies will put you under an NDA for the summer. That's totally reasonable. And if you're under an NDA, just say that you are. If we ask questions about some project you worked on and you can't talk about it because of some NDA, just say, I actually can't talk about that, I'm under an NDA. We'll say, okay, great, that's fine. We'll back off. If you're just sort of like cagey and don't disclose that, and you're like not giving me any answers, And I'm sort of just going to be wondering, like, oh, this is sort of weird. Like, maybe they didn't understand the project that well, or there's some other reason they're not talking about it. And so if that reason is just an NDA, just tell your interviewer. It makes your life a lot easier. OK, so that's everything before the interview. So I'm going to hand it off to Jelle, who's going to talk about preparing for the interview.
Yeah, can you guys all hear me? Great. Yeah, so I'm going to talk a little bit about how you should prepare for your interviews, what it's going to be like during the interview. First, a long-term thing you should do is interviews are preparing you to be a good software engineer. Interviews are about assessing whether you're going to be a good software engineer. So you should do things that make you a better software engineer, like do engineering projects, take classes like, say, CS124 on algorithms to learn more about the problems that you might get in an interview. And also just do more interviews that will tell you more about what interviews are like. You can do practice interviews. We're going to give some this weekend. You can interview at more companies and learn more about what it's like. You can talk to people about what it's like. But in the short term, you might not be able to do all those things. So it's also useful to just practice some of the basics. Tommy already talked about some things that you might encounter, but here's some more common themes that you will see in interviews that you just need to know how to do. Like, if you're working in an object-oriented language, you need to know how to define a class. You need to know how the methods on that class work and how to call them and to define them. You need to know how to do some simple things with a linked list, like add things to it, take its length, remove things. You also be working with trees. You need to know how to search it. And similarly with arrays and hash tables, you also often encounter. So if you know these things, it's going to be easier to focus on the precise problem that you're dealing with and not have to worry about the details of, like, how do I define a function? How do I do this really simple thing? And also, as you do more practice, like as you do practice problem, you talk to people, you do more interviews, you're going to notice common things. Like maybe there's more things that you often need that are not in the list that I just gave. So it's going to be a sign to you that you should also know these things well and learn them better. You also just want to practice a variety of problems. There's a lot of possible algorithms questions. The more you see of them, the more you're going to be able to be prepared when you see a new one. And in general, there's like this toolbox of common techniques that you'll often find useful. Just like the list of common things I just mentioned. But in a lot of questions you see like recursion. You need to understand how recursion works. You need to know how to write a recursive function. Dynamic programming happens a lot, so you need to understand the technique and understand how to use it and understand when it applies. You often be asked about time complexity, like does this take quadratic time or linear time or whatever? So you need to understand how that works and be able to recognize the time complexity of a piece of code that you just wrote. You often be asked a problem that involves trees or graphs. So you need to know in general how those work and how to operate on them. And there might be more data structures that you encounter, like hash tables are going to be helpful for a ton of problems, so you need to know them really well. There's lots of other data structures that you might find useful for algorithms problems. And the more of these things you know, the easier it's going to be to see when you see a problem that this tool that you already know about applies to it. And then maybe the problem becomes really easy. So Tommy already gave you this list, but we're going to give it again because these are really important. These are some of the things that you're going to encounter most often in algorithms interviews. So you should just know them really well. Arrays are like useful for dynamic programming, for lots of other things. Linked lists are extremely common in all kinds of data structures and algorithms. Hash tables, as I said, are important. Memorization is very often useful in like getting the time complexity of a problem better. So next I'm going to just go over what happens during an interview from the beginning to the end and how you should approach each of those parts. So at the beginning, you're usually going to spend a couple of minutes just talking to the interviewer about like your past experience or something. A lot of that's just to break the ice, to make sure that you're comfortable talking to them, that you aren't just thrown immediately into a difficult technical problem, and you have a chance to like get to know them a little bit, and the interviewer has a chance to get to know you. So you might be asked about like some past projects, so you can talk about it for a little bit, say what was interesting in that project, and just generally let the interviewer get to know you. And also, if anything is on your resume, you should be able to explain it and talk intelligently about it. If you put on your resume, like David did, that you're really good at assembly language, then somebody might ask you a question like, tell me something about assembly language, write some assembly language. If you don't want to do that, don't put it on your resume. Don't talk too long here. The main part of the interview is going to be about coding or algorithms. So if you spend 20 minutes about some past projects, you're not going to have any time to let the interviewer know that you can actually code well. So they won't be able to see your skills. So after that, you're probably going to move into the actual technical part of the interview. And one thing I want to discuss there is that people will sometimes say, like, why do you have to interview in algorithms? Because in a real life CS job, you're probably not going to be implementing this sort of algorithm most of the time. And that's true to some extent, but it turns out that being able to solve algorithms problems is actually a predictor to some extent of being good at practical programming, because it shows problem-solving skills that you're also going to be needing in your actual job. And in general, knowledge of data structures is just a good indicator of somebody being a CS student who knows what they're doing and generally understands what's going on. So you're probably going to get at least one, possibly more coding problems, focusing on some sort of data structure or some sort of algorithm. So what's going to happen is that the interviewer is going to ask you a question, like, as Tommy said, reverse a string. And then they're going to ask you to tell them how to solve this problem. So usually you first explain, you think about it for a little bit, but then you explain how you're generally approaching this problem. Like, what is the general approach you're taking? Why is this approach correct? And things like that. You also often be asked to analyze the time complexity as well as the space complexity of the solution. Like, you can say this takes linear space and exponential time or whatever. You're going to be writing code. It's going to be usually either on a whiteboard or in some sort of online editor where you can just write code. Most of the time you get a choice of what language you want to use. So they will ask you just do it in whatever language you prefer using. Still, if you use a language that nobody understands, it might make it harder for the interviewer to see what's going on, make it harder for them to assess you. So it's better to use a more commonly used language. And as you write your code, you're often going to test it. If you write in an online coder, you might be able to actually run the code and see that it works. If it's on a whiteboard, you might just step through the code and talk it out and make sure that it's correct. You'll often be asked to write test cases. So just write some exhaustive set of possible inputs to your function and make sure that it gives the correct set of outputs. So next, we're going to see what it's actually like by doing a mock interview.
Okay, so first, Jelle is going to interview me. So I'm going to go this way. And so we're going to use what Jelle was just mentioning. So this is a tool called CoderPad. You might see exactly this or something like it at many of the companies you interview at. Basically, this is just a way where I can write some code here, click run, and then I'll see the output over there on the right. Okay, so I will be the interviewee first.
Yeah, hi Tommy. Could you implement a function for me that outputs the nth Fibonacci number in binary?
Yep.
So maybe as you do this, can you tell me a little bit about what you're doing and why you're doing?
One sec. Pause.
Only you can do that in an interview.
Yeah. Oh, you can. Okay, unpause. Okay, done.
Okay, can you test the solution now?
I'm done, it works.
Can you just show me that it works by giving some examples?
Okay. All right, I tested on 5. Let's go through the Fibonacci things. 0, 1, 1, 2, 3 is the fifth. 3 in binary is 1, 1. It works.
Can you test on some more cases, maybe like 6?
I mean, this works.
Let's try another one.
Is that right?
I think 8 is not a valid number in binary.
All right. No, I got it.
Wait, why are you making these changes?
I'm just trying to fix it. Just set off by 1 error. Okay, so we're gonna stop there. So what are some things that you noticed that were good or bad about that interview? Just raise your hand and I'll, yeah.
You weren't super willing to talk through your thinking as you were writing the code.
Yes, exactly. So I just stood there silently. In fact, the interviewer tried to help me by saying, what are you thinking about? And I did not. So not good to just be silent and not say what you're thinking. What else? Yes?
You should never make random changes to try to find a bug, like the things that we were going to be said. You should always talk through the changes that you're making.
Yeah, exactly. So I was just sort of like making random changes and rerunning. I didn't have a systematic approach to debugging. I was just sort of changing stuff and rerunning and sort of praying that it would work when it didn't. What else?
You were confident.
I was very confident. I guess that's a good or bad thing, I guess. But yeah, I was definitely confident that this was right, when in reality it is nowhere near correct. How about one more? Good or bad? Yep.
You didn't ask for like scenarios or test cases.
Yeah, exactly. So that's something here is kind of like one gotcha you learn with the Fibonacci problem is it could be 0 indexed or it could be 1 indexed. It might start with 0 or 1 or whatever. I didn't ask any of that up front. I made a big assumption that it's going to start the first 2 digits are 0 and 1 and it's going to go from there. So I didn't verify with the interviewer what the output was going to be. I just sort of assumed what it was going to be. Another thing related to that is I didn't test my code. I just sort of said done and that was the end of it. Instead, the interviewer had to prompt me to actually write test cases, and then it turned out that was wrong. So that's not great because I had no confidence, even though I appeared to be confident, I had no confidence that my code was actually correct because it didn't have any test cases. So okay, so let's do one more mock interview. So this time, I am going to interview Jelle. Hello, Jelle.
Hi, Tommy.
How's it going?
Good, how are you?
Same. I'm good too. So for this problem, so you're going to implement the nth Fibonacci number, and it's going to return the result in binary.
Okay, so it's fine if I do that by just calculating a Fibonacci number normally and then converting the output to binary?
Yeah, that sounds like a good approach.
And is it okay if I use the really inefficient solution for Fibonacci where it goes all exponential?
Yeah, let's just start there, and then we can
Okay.
optimize it later.
Okay, let me first come up with some test cases. So actually, let me write out the functions I'm going to use. I'm first going to make a function that returns the nth Fibonacci number. Well, the doc string is going to take too much time. And then I'm going to convert that to binary. That's actually going to be really easy in Python. You can just do this. So let me come up with some test cases. The 0th Fibonacci number is 0, so that's going to be this in binary. The 1th is going to be 1, the first. The second is also 1. And that's enough for now. So let's implement this. Fibonacci is recursive if the n is less than 2, so if it's the 0th or 1st number, it's just n directly. The 0th is 0 and the 1st is 1. And otherwise, it's going to be the sum of the previous two, so fib n minus 1 and fib n minus 2. Does that make sense to you?
Yeah, looks good.
Okay, so let's see if that works for my test cases. Is anything happening? Oh, it's up here somewhere.
Yeah, just do it right.
Okay, it's actually worked correctly, but I only tested a few cases. I'm not really sure that it works correctly for a bigger Fibonacci number with just this. So the third Fibonacci number is 2, which is 0B10 in binary. After that you get 3, which is going to be this. Then you get 5.
Okay, and we'll stop the interview there. So very different. What was good and bad about that interview? Yeah?
He communicated with you.
Yeah, so he communicated with me. So we did things like he verified the output. I could say, yep, these test cases look the correct test cases, vocalized his thought process, said things like, okay, if it's less than 2, it's just going to be itself because we've defined Fibonacci sequence in this way. So communicated with me throughout. What else? Yeah?
Before starting, he asked a few really questions.
Yeah, exactly. So the first thing he did was ask a bunch of questions. This isn't a super open-ended problem, but there are still some things that you might want to clarify before putting pen to paper. And so Jelle asked some clarifying questions before he did anything with the solution. What else? Yeah?
Use the native binary conversion as opposed to trying to implement his own.
Yeah, exactly. So two things here. The first is that Jelle knows Python really well. I know this for a fact and in the hypothetical. And so he knew that there's a function already that existed to convert some number into a string binary representation. And so because he knew that, he was able to use that. But he also checked in with me as the interviewer. Is it okay if I use this built-in method? And if I wanted him to implement this and that was part of the problem, I would have said, no, actually, can you implement this yourself? But in this case, I didn't care. And so I said, yep, feel free to use that built-in method. What else? Yeah? Yeah, exactly. So that could have been because I cut Jelle off, but that's true. When you're doing when these test cases, also think about edge cases like putting in none or putting in non-integer. And if you're not sure what types of inputs might be passed to the function, also ask your interviewer that. Because I might say something like, oh yeah, don't worry about negative numbers or don't worry about this type of input. And if you go write a bunch of edge cases before verifying with the interviewer, you're also going to waste time that way. Yeah?
So before implementing his code, he talked through the logic that he was going through and finding concepts.
Yeah, exactly. So here, we notice that this is nicely decomposed into two separate functions. You have one function that returns the binary representation, one function that returns the Fibonacci number. And so you sort of explained that to me up front. I said, yep, that makes sense. And then another nice property of this solution is that if he wanted, he could test this function separately from this function. So in this case, it all worked. But if there was some bug, let's say somewhere, then the first thing you could have done was just test fib on its own and then test binary fib, which makes debugging a lot easier. Where I was just sort of making random changes and rerunning it, he's able to narrow the problem space down a lot more by figuring out, okay, is the problem in this function or this function? And if it's in one of them, you no longer have to worry about the rest. So sort of that like divide and conquer approach to debugging. Let's do one more, good or bad. Yeah?
He asked you if he could implement something that was exponential time, and you said yes.
Yeah, exactly. So he said up front, he said, let's start with the naive solution. He checked in with me that that was OK to write a naive solution first. Most interviewers are going to say, yep, let's start there. And then he's able to write this naive solution. So let's say hypothetically that we weren't able to get to the optimized solution. At least the interview would have come out with something. He had something working. I saw his thought process. We were communicating. That's a lot better than him trying to start with the iterative version or something that's not going to be exponential. So started with naive, clarified that with me, and then implemented it, and then came out with some sort of working something. OK, let's jump back to the slides.
Yeah, after we've seen that, let's go a little bit more on what you should do. A lot of this is going to reflect what Tommy just didn't do and what I did do. when you get a problem, you've seen it before, you should tell your interviewer. This actually didn't come up. If you don't do that and you just implement the solution immediately without thinking about it, it's actually going to look really bad because it will tell the interviewer that you did know this problem, you didn't tell them, and therefore you are lying, and we probably don't want you to work for us. We also want to make sure you understand the problem well. So this is something that just came up. I asked a bunch of questions to clarify exactly what he expected from me and what the output should look like. So if there's anything unclear about what the problem is like, just ask the interviewer. You can also use this to buy some time to make sure you have time to think about how to implement it. You want to agree on what the output should look like. Like in my case, I wrote test cases that showed exactly what this function would output, and the interviewer could have said, no, I want something else. And in general, it's more important to see what the process is by which you get to a solution than exactly what your solution is. So it's really useful to the interviewer if you just talk through what you're thinking and how you're approaching the problem, even through multiple approaches. Like you might say, there's multiple ways to do it. Here's one way, here's why it's good, here's why it's bad. You want to perhaps even like draw a diagram or something, or go through test cases to explain exactly what you're thinking, like what you're thinking the output should be like, what you're thinking the solution should look like. And in general, just convince your programmer that this way of solving the problem will actually work well. And once you're there, you can start writing the code. While you do that, it's important to keep talking, communicate to the interviewer what you're doing, why you're writing a line of code. And as you do it, it's also important to keep your code high quality. We know it's really quick and you don't have time to do everything maybe, but you should still keep your code understandable. Don't like have completely messed up indentation or name all your variables foobar and buzz or something. If it's at all possible, use helper functions so that you can break up your logic, perhaps test them independently, also write them independently, which makes it easier to understand your code as you're writing it. If you had a whiteboard, it might be harder because you have limited space and it's harder to move code around. So you can just talk to your interviewer like, I would move this logic to a helper function if I had more space, but maybe you can't easily do it. If you code on a computer, there's kind of this dilemma where if you just write all of your code and then run it, it's probably not going to work because you will have made some mistake there, some small mistake somewhere. But if you keep running your code after every line, it looks kind of bad and it takes a really long time. So the best thing to do is to go somewhere in between where you can break your code into smaller helper functions. As you finish each of them, test it. I didn't really do that, I guess, just now because it was a very simple problem, but if it's a more complicated problem, it makes sense to write one function, then make sure it writes, then write another function until you've got the whole problem. If you're debugging, it's kind of similar. It's bad to just stare at your code and not talk because then the interviewer is sitting there and doesn't know anything about what you're thinking or how you're approaching the problem. So keep talking about what you think the problem is and how you're thinking to fix it. It's also really bad to just make random changes, like change in minus or plus, add a random -1 or +1 somewhere, because it shows that you don't actually understand what you're doing. And what we're looking for is that you actually understand the problem that you've been given and know how to solve it well. So you should use a systematic debugging approach where maybe you first establish that one function works correctly, and after that you establish that another function works correctly until you've found the place in your code where it's not working well. And then every time you are at an interval where you have like a debugging breakpoint or something, you can run your code to inspect the outputs and see what's going on. On a whiteboard, it's going to look pretty different from if you're actually doing it on a computer, because you cannot run your code directly, of course. But there's still some similarities. Debugging will usually look like you go over the code, like maybe you write out every variable that you have and what its value is, and then just go over your code in a loop or something and keep track of the value of each variable. Some things to watch out for is that you might well run out of space. So always start at the top of the whiteboard so that you have all the way to the bottom to write code. It's going to be harder to refactor things or move code around, so I guess try to get it right the first time. And yeah, debugging is going to be by stepping through the code. The final thing is it's really important to communicate. So it's much better to talk too much and maybe say a bit too more about your coding problem than too little. If you don't say anything during your coding problem, the interviewer will have no idea what you're on about, will have no signal that you actually understand what's going on or understand what the problem is about. It's also important to listen very carefully for what the interviewer says, because they might have hints or cues as to how to solve the problem or as to what a good approach to the problem is. And in general, an interview is not just about writing good code and solving the algorithmic problem. Because at a real software engineering company, you're always working with other people. So we're also looking for whether you can work with other people well, like whether you can explain what you're doing to other people, because as you work on an extra project at the company, you're going to be working with other people on your project, and other people have to read your code and understand your code. And if you cannot explain what you're doing, then you're not going to be a very good software engineer. At the end of the interview, usually the interviewer will ask you to ask some questions to the interviewer about like their work or something like that. And that's actually, you should think of that as a pretty important part of the interview, because it's your chance to know more about the company. And as Tommy said at the beginning, you should think a lot about what company is the right fit for you and what you're looking for in your internship or your full-time job. So this is your chance to learn more from the person who actually works there, but what it's like to work at the company you're interviewing at. So you can learn things about like the culture, like are people expected to work all the way through the weekends? If you don't want to work all the way through the weekends, that's going to be a bad sign. You can learn about whether there's opportunities to learn from other people, like what kind of mentorship opportunities are available at the company. How do people grow in their jobs? You can learn about the types of problems the company is dealing with. Like you can ask the interviewer what the problems are that the company is running into and is trying to solve. And you can see whether those are things that interest you. It might also just be interesting to learn about the personal path of the engineer you're interviewing. Like, how did they get to this job? And what kind of people are they? Because the interviewer is going to be one of the people at the company you're working with. So it will give you some information about what kind of people you'll be working with. Yeah, now I'm going to turn it over back to Tommy.
Okay, so last we're going to talk about sort of after the interview. Before I do that, I just want to echo one of Jelle's points. If my biggest pet peeve on resumes is charts, my biggest pet peeve during interviewing is when people don't listen to hints. We have a few different practical interviews at Quora, and it's really, really common experience for me to say something like, if they can't find the problem, I might say something like, hey, maybe the problem has to do with this module. And someone will say, no, it doesn't. Like, no, it does. That's why I'm saying it. This happens way, 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 way more than you'd expect. So if the interviewer is, as an interviewer, I hate to see people struggle too. It's sad for me if people are struggling, and I want to help people. We want to help people succeed and showcase their skills. So often the interviewer will try to help you through a problem. And so if they're trying to do that, take them up on it. We both want to see, our incentives are aligned. We both want a successful interview here. So as they're pointing you in the right direction, make sure you do that, or take that advice rather. Okay, so sort of after the interview, so after you do an interview, if you don't do well, which is going to happen to everybody, you've heard horror stories from everybody about an interview going badly. It's inevitable. It's going to happen. So treat that as a learning experience. It just so happens that interview experience and actual productivity at a company many times can be uncorrelated, and that someone who's a bad interviewer might be a great engineer. But that's okay. It's sort of like the best proxy we have, and so just understand that these bad interviews are going to happen. It's okay. Don't get too discouraged, and try to view it as a learning experience. As a small piece of advice, something I do not recommend is if you go through a bad interview is asking the company for feedback. There's actually legal reasons why companies often cannot do this and provide fine-grained feedback of what went well and what didn't. So often asking that question can put the company in sort of this weird, awkward place that neither one of you want to be in. So try to reflect on yourselves and go through other practice interviews, either with these workshops or with your friends to try to get information rather than asking the companies for it directly. So takeaways from today. So everyone who goes through one of our mock interviews, we're going to be giving a copy of Cracking the Code interview. This is written by Gail Lackman-McDowell, who just happens to be a top writer on Quora, who knows a ton about these types of problems. So this has a bunch of problems in it, and actually going through and doing them by hand is going to be really, really helpful. So in particular, I'd recommend not just looking at a problem saying, oh yeah, I know how to do that, and then looking at the answer key and being like, oh yeah, I totally would have done it. Actually go through and write the answers to those problems and make sure you do that. Something else to take away from today is go home and make sure you have all the basics down cold. It really sucks to be in an interview where the interviewee spends 10 minutes trying to remember how to initialize an array in Java, which happens to be weird. But having that down cold, practicing those things that we mentioned, how to define a class, how to BFS a tree, how to create a linked list, just go back and practice them. Pick a language, know it really well, and start building that toolbox. And then once you have that toolbox, then start jumping into these practice problems, do a variety of those problems. And also, if you do a problem and you find that there's a tool missing in your toolbox, you needed to use some data structure of this problem that you didn't know off the top of your head, then go back and learn that and add that to the list of things you have down cold. It turns out that many interview problems are just sort of rewritings of other problems, and that once you learn how to recognize, okay, this is definitely just a sorting problem, or this is just a shortest path problem, the more effective you're going to be. So the more problems you see, the more problems you actually work through, by hand on a whiteboard or with a pencil in those sort of accurate simulation environments, the better you're going to be here. So those are sort of the short-term takeaways. And in the long term, as Jelle mentioned, just do more of these. The more interviews you do, the better you're going to get at it. Do practice interviews with your friends. If you're all going through interview processes, you all sort of know what it's like to interview somebody. It turns out it's not that hard. So you can do this with your friends. Just spend more time programming. Take these data structures and algorithms classes, and then you will be successful. Don't worry. So with that, I just wanted to open up to Q&A. We have 20, 30 minutes here. We're also going to hang out afterwards, but would love to answer any questions you have now. Yes?
For a coding question, if you know an inbuilt function in your language exists and you don't remember the exact syntax, how would you approach that?
Yeah, so I would say exactly that out loud. I would say, okay, I know there's a Java function to convert this array to a linked list. I don't remember what it's called, but can I assume it's called as list or something? And most of the time, interviewers say like, oh yeah, that's fine, whatever, I don't know what it's called either. But that's a lot better. Just vocalize that, show that you know the language, even if you don't know the exact method name, that's fine. As an interviewer, I'm not looking to quiz you on like how well do you know java.util.arrays or something. We're just looking to solve the problem together, and so just vocalize that and check that assumption with the interviewer. Yeah. Sorry, would you need a language besides Python? So the question is, so could you just learn one language and probably get through all of your interviews with just that?
Well, I mean, I heard Python specifically isn't, I was reading an outdated version, I think, of the coding interview book, but I think it said that it needed Java at least, it didn't really mention Python.
Oh, okay, sure. So in general, I do think you can get through most of your interviews by just learning one language, learning that well. I personally think Python is a good interviewing language just because the syntax is really easy. It's easy to do a lot of things like create an array. I think I remember reading similar things, and the argument that was made was that Java has built-in data structures for everything you can imagine. Like it has built-in, like an LRU cache or a heap or things, where Python doesn't have those built in. I personally don't think that's super important. Other interviewers might disagree with me, so this is just my view. I don't think having those data structures built in is super important, because as an interviewer, if someone says to me, okay, I want to use a heap, can I just assume this class exists somewhere and it has these methods like add, remove, whatever? I'll probably just say yes, even if it doesn't technically exist in the language. So I personally think Python's a really good interviewing language. And if you know it, then I would just sort of learn that really well and try to get through interviews with that. In general, languages where it's easy to do things, like create a dictionary or append to an array or things like that, are better interviewing languages. So as an example, C is not a great interviewing language. It is hard to append to an array. It is hard to reverse a string. So I try to avoid languages like that if you can. Does that answer the question? Okay. Yeah.
I don't know the other people in the room, but I know like halfway of Java, Python, and C. So like the syntax gets really confusing. I like combine languages together and just writing it out. So how important is syntax when it comes to the interview and you're like analyzing my coding skills?
Yeah. So the question is how important how important is syntax to an interview? So the answer is it depends. If you're on a whiteboard, it's not that important. If you use a curly brace instead of a bracket on a whiteboard, I'm probably not going to notice or just sort of softly correct you, and it's fine. But if you're at a computer and the expectation is that your code is going to run and produce output, then syntax matters a lot. Because if you write code and you have a syntax error, now immediately you're stressed, like, oh crap, how do I create an array? Is this the Java way or the Python way? That's just going to stress you out. It's going to take time. It's going to prevent you from getting this correct solution written. So that's where I'd advise you just to pick one language and try to learn that as best you possibly can, and then go into your interview with sort of that predetermined. So go into an interview knowing I'm going to use Python today. I know all this stuff about Python, rather than having to worry about that when a question is asked. Yeah.
So I think one of the things you mentioned in the presentation was that if you've seen a problem before, you should say so. So like, how would that work? So like, if they asked you to traverse a binary tree, then would you tell the interviewer like, oh, I've seen this before, and then you just explain how to do it?
Yeah. So question is, we mentioned you should always tell your interviewer if you've seen a problem before. How do you do that? Yes, I think that's basically the idea. So if someone says, print this matrix in a spiral, that's like one pretty common interviewing problem. Just say, hey, I've actually done this one before. The interviewer will do one of two things. They'll say either, okay, that's fine, just do it again anyway, and we'll go through it quickly and move on to something else. Or the interviewer will say, okay, great, let's do something else then, because that's more interesting. So yeah, you don't have to worry too much about how you phrase it. Just be direct and say, hey, I've actually done the spiral matrix problem a couple days ago, and I was practicing, so just wanted to let you know that. And the interviewer will always be like, oh, okay, great. Hopefully they have other problems, but they probably do. Yeah?
Are you supposed to write comments in your code, or just like talking it out verbally is enough?
Yeah, that's a good question. So the question is, excuse me, should you write comments in your code, or is talking it out generally enough? I think generally, if comments are helpful to you, you should feel free to write them. In particular, if you're writing a long coding function or a long coding problem, writing a long function, and you're sort of starting to get lost on your own, then write some comments to sort of leave markers to yourself or remind yourself how the code works. But in general, if someone goes through an interview and doesn't write any comments, I don't think that's a bad thing, because you are talking about it and vocalizing it out loud. The comments they take time to write, and they're not providing additional information to me. But if they're helpful to you and you feel like they're useful, then you should write them. Yeah.
Would it hurt you to interview with the same company more than once?
Yeah, so does it hurt you to interview with the same company more than once? I don't think so. So I think if you interview with a company, let's say you don't get an offer, and then you come back next year and interview again, that's often a great signal. It shows to the company that you're interested, you really want to work here. It didn't go well last year, but then you did a different internship, you took some more classes, and you're still interested, and you're not too discouraged. That's certainly a really good signal. Something not to do is if you do an interview, it doesn't go well, you get a rejection email, don't then reapply the next day, because that doesn't make you look good. It just sort of makes you look unaware. So I'd say in general, wait at least a year or so after applying. With summer internships, that's going to happen automatically because your next internship is the summer. So that's generally the amount of time I'd recommend. At least 6 months, definitely at least 6 months, but in general, at least a year or so is a good window. Yeah. Yeah. So writing code and commenting is sort of a whiteboard, different than a computer. I think it's sort of the same thing. If commenting is helpful for you, then you should do that. In particular, commenting on a whiteboard is a little bit harder just because it takes even more time. It gets a lot faster to type a comment than it is to write a comment. So if it's really helpful for you, then you could do it. But if not, then I would just sort of, in the whiteboard case, just try to avoid comments altogether, unless it's really helpful for you. Because as an interviewer, I'm just going to be thinking like, I just want to go faster, like this is taking time. I'm not getting signal from you writing a comment. And as an interviewer, my goal is to get as much signal out of the interview as I possibly can. So if you're doing things that are not giving me signal, then I'm not going to get as much signal out of the interview, which is then in turn bad for you. Yeah?
When you're working on problems, do you have to code right away, or can you just like ask for a few minutes just to like think about it?
Yeah, so when you're working on a problem, can you like ask a few minutes to think about it? I think that's totally okay. I would much rather someone take a few minutes to think about it, particularly over the phone. If someone says, "Oh, I have some paper here. Do you mind if I just write some things down?" I'll say like, "Oh, sure. If you can type them, like type them out so I can see them too, and we can be more on the same page." But in general, if someone says like, "I'm just going to think about this for a few minutes," and then take some time, but then starts vocalizing, I think that's good. And generally, you should never start coding right away anyway. You should always start asking clarifying questions, make sure you understand the problem, make sure you agree on a set of inputs and outputs. And as Jelle said, often that process can buy you some time, and you get some time to start thinking about it as you're going through that process. But if you do want a few more minutes to like draw out some diagram or something that just can't be typed on a shared coder pad, then just say that out loud. Don't just be silent for a couple minutes without telling your interviewer that's what you're doing. But if you want to draw something out, then do that. Yeah?
What's a good approach to indicating to your interviewer that you were just given a problem that you know yourself that you can't solve?
Interesting. So what's a good approach to a problem that you know you can't solve? So how do you know you can't solve it?
Or like maybe you're not familiar with the data structure, like just fundamentally you know you don't have the tools to approach the problem.
Yeah, so I guess if you don't think you have the tools, I would just sort of like talk through that with the interviewer. You might say something like, I think this problem could use a heap. I'm not too familiar with how a heap works. And the interviewer will probably say like, oh, that's okay. Like, I'll give you some information about how the data structure works. Basically, the more you're communicating with me, and the more opportunities you're giving me to help you. And so, obviously, it's better if you know the data structure offhand. But if you're communicating with me, and then I can start like helping you along and giving you some tools, and then if you can use those tools effectively, that still might be a really good interview because you've just shown me that you've given some unknown. You basically learned some new thing on the spot and then used it well. That's still a really positive signal and might show me like, okay, this is actually a really good person because they're going to have some unknown problem and be able to solve it right away. So again, the more vocal you can be with the interviewer, the better. I wouldn't just say like, oh, I don't know how to do it, because that's sort of like defeatist. I would just say, oh, I think this would require this type of search. I'm not super familiar with that search though. Then the interviewer can jump in and start having a conversation. Yeah.
With any interview, how important is it to, I guess, get a referral versus applying for something like
Yeah. So how important is it? Excuse me. How important is it to get a referral versus applying through Crimson Careers, the like on-site interview thing? In general, referrals are helpful. Often, most companies you're not at a huge disadvantage if you don't have a referral. In particular, you mentioned Crimson Careers. Companies that do come on-site, that's usually the best way to get in contact with them. Just makes scheduling from our end a lot easier. We just like get back this list and it's like all scheduled and we're like super. So if you can use that, do so. So referrals are helpful, but they're rarely situations where if you don't have a referral, it's impossible to work somewhere. So if you do know someone who currently works at that company or someone who previously worked there, go for it. There's often nothing to lose with the referral, but at the same time, especially with like new grads, we don't expect that any new grad has a referral or knows someone at the company, and so which is sort of different than let's say a 5-person startup hiring only experienced people. There might be different expectations there. So for someone in your role, I wouldn't worry too much about a referral because many companies don't. That's not our primary funnel or source for new grads is referrals. It's more people applying through Crimson Careers or through the careers page or coming to us at a career fair or things like that. Yeah.
I'm going to repeat a question I asked last year.
Okay.
Really good session. Portfolios versus GitHub, and then, how do they play in? Because I often get asked by students, or I tell students in different areas to do portfolios or to have their GitHub. And then you also mentioned LinkedIn on here. So can you just talk about those and when they're useful, when they're not?
Sure. So question is, so when are some of these external links like portfolios, LinkedIn, GitHub, when are they useful, when are they not? So I'll start with portfolios. So if you're looking for a design position, or maybe a sort of like really front-end position where we can show something off that's visual and interactive and usable, that's when a portfolio is helpful. A portfolio is not helpful if you're someone looking for like a back-end role, or you're doing machine learning stuff, or things like that don't really lend themselves to a portfolio. So that's when it's not helpful. So design roles, that's good. Sort of a lot of engineering roles, not so much. With GitHub, would also include a link to your GitHub if it includes these interesting personal projects. So if you've written some script, I remember when I was in college, I had this script that I used to use the Asana API to manage some tasks on problem sets or something super lame. But it worked and it was on my GitHub, and so I was like, okay, I'll include that as an example of this interesting personal project. So if you have those, then that's what I'd include the GitHub link. Particularly in these engineering-focused roles, that's where GitHub is a little more relevant. But if your GitHub is just empty and maybe just contains forks of Ruby on Rails that you didn't actually do anything to, then that's not worth showcasing. So if it's something you're proud of and you want to show recruiters, then include it. Otherwise, don't feel like you're obligated to include it. And then finally, LinkedIn. LinkedIn and resumes, I think, are pretty equivalent. If you give me a good resume, that's probably enough, but some people don't have resumes and they'll just give a LinkedIn profile because it has all the same information a resume would. That's fine too. Generally, resumes and LinkedIn they tend to have the same exact information. So if you only have one of them, that's fine. And if you have one, I'd recommend a resume, not just having a LinkedIn. But yeah, pretty similar information there. Yeah.
What quantity and magnitude of projects on GitHub is actually matters? At what point in time is your GitHub good enough that people care about it?
Yeah, that's a good question. So at what point in time is your GitHub good enough that people care about it? There's no hard line that says okay, if you don't have 3, I'm going to ding you or something. I would say if it's something that you're proud of and something that you'd want to show somebody, then you should show somebody. Again, most hiring managers, recruiters aren't going to spend a ton of time doing a code review of your last 3 commits on some side project. They're just sort of looking for are they working on something? Is this cool? Is this is it show some passion for some side project? So I say it's up to you. If you're proud of it, then you should show it. And if you're not, then you shouldn't. Even if you just have one interesting project that you really like, that's better than nothing. Yeah?
So going off of that, if you have an interesting project or several interesting projects, a lot of mine are kind of hacked together because it's just a fun little thing. I'm not putting much time into thinking about how it works because it's a pretty small project and not something I'm trying to develop. At what point, how much should I care about the quality of that code?
Yeah, so how much should we care about the code quality of the GitHub projects you're showcasing? Again, I think it's also up to you. I think, again, engineers aren't going to spend time really understanding the code quality and reviewing it. They're more looking for, are they doing some stuff that's interesting? Are they passionate about some area? So again, it's up to you. If you're not proud of something and you think this is terrible and you wouldn't want anyone to look at it, then don't. But if you're oh, this is pretty good, I made it at a hackathon, there's some improvements that could be made, and it's a little hacky, but it's still something I'm proud of, then I would show it. That's sort of the best bar I can give for what you should showcase is, do you want to showcase this? Which sounds like a weird bar, but it's probably the best one.
Yeah, thanks.
Yeah? What would you say is typical success rate in terms of moving on to the next step versus not? I can't disclose Quora's success rates, unfortunately, but it's honestly going to vary a lot by company. These large companies who have a ton of applicants, Google advertises its conversion rate to be in the single-digit percents, just because they have so many applicants that many of that just get filtered out at the resume stage. So I can't disclose any, but it's going to vary a ton based on just interview volume and size of company. So it's not a super important number, I think. More important takeaway is if you fail, that's okay. Yeah.
So if people are looking at your resume for max 30 seconds, then how realistic is it that they're going to look at your GitHub?
Yeah, no, it's a good question. So basically, if someone's looking at your resume for 30 seconds, are they going to look at your GitHub? So where it comes in handy is if you don't have a lot of internships. So if you give me a resume and don't have any internships yet because you're a freshman, you just have a couple courses, but then you have a GitHub where there's some cool project that you're proud of, or you attended a hackathon, that might be the difference between getting an interview and not getting an interview. Whereas if you're someone who has 3 internships at well-known tech companies and things like that, then it's not as helpful. So I think things like that are better for people who don't have much else on their resume, which is everybody at some point in time. But if you're sort of past that point, then I think it's a little less important. Yeah?
What types of opportunities does Quora offer?
Yeah, so what opportunities does Quora offer to students? That's great. So we do internships for engineering, design, and data science. We do internships throughout the year. Because we're sort of this like smaller, mid-sized company, we typically look, we don't have any programs targeted at freshmen or targeted at people who don't have much computer programming experience before. But if you've done an internship before and you've taken 4 to 6 CS classes-ish, that's sort of like it'll probably be a pretty good fit. So we're interviewing always, including now. So if you're interested, definitely talk to me. Yeah?
How do the data science questions differ from coding or from like the software engineering questions?
Yeah, so how do data science questions differ from engineering questions? Really good question. Unfortunately, I don't have too many specifics since I've only been on a limited number of data science loops. But typically, a data science question might be something like, here's some new product feature we want to launch. What metrics should we be looking at? How should we expect those metrics to move? What sorts of hypotheses would you form? Or rather than writing a Python question, we might give you a question that's answered with a big SQL query. So being aware of how joins and order bys and group bys, how all that stuff works. I don't know. Do you know any data science questions?
Yeah, it's basically like that. We also ask some coding questions to data science. But data science in general is the same category of questions. You might also have practical questions like run a query on a real data set and understand some problem with it. As Tommy says, you can have questions about like how would you evaluate this feature, how would you do this in SQL and things like that.
Yeah, or I guess like data modeling ones is another common one. Like here's some data set, like answer these questions about this data set, like produce these visualizations or models and things like that.
You might also be expected to understand some statistics, like what is the best statistical test to use for evaluating this particular metric.
Yeah.
Same question for PMing. Like how do those interviews differ and are they similar? I imagine there's coding portions to those often, but.
Yeah, that's also going to vary by company a lot. Like some companies have, every PM is really technical. Quora falls into this category. I think all of our PMs have some sort of CS degree or like programming experience or something. Where other companies, that's like less important for PMs. And so there's a spectrum of technical questions. I'd guess that they'll include some sort of technical component in all of them. But I think PM interview questions are often more scenario based. Like, okay, we're going to be how would you? There's this problem in the product. What feature would you develop in order to solve it? If the company is pretty quantitative, you might get some of these metrics questions as well, like what metrics should we use to evaluate the success or failure of something. But they're more, product focused. Communication is a lot more important there. Sort of the bar for solid communication for a PM is a lot higher than it is for an engineer. Not that it's 0 for an engineer, but it might be similar types of questions, but evaluating different things.
Thanks.
Yeah.
What are the internships for inexperienced students?
Sorry, I couldn't hear you.
Like the internships for freshmen or sophomore who haven't done much CS classes, what are they like?
Yeah, so basically, what are these different types of internships like? So I think it's also going to vary a lot by company. Different companies might design different internship programs. But typically, these freshman or sophomore programs, you're just given a lot more mentorship. You're given a less autonomy in the sense that we don't want anyone to go and bring the product down or something like that. So you might be working on a project that's a little more isolated from the main project, but the emphasis is on like learning something. You might be like building a demo for some new feature. Basically, the emphasis there is just on learning and working with experienced people, and that's sort of the expectation. Where a more experienced internship, there'll probably be a little less focus on learning and more expectation that you're going to produce meaningful output that helps the company in this way. So, more impact focused than learning focused. But it's going to vary a lot by company. Yeah, go ahead.
And do the interviews vary? Like, are they different from the interviews for like junior and senior?
Yeah, it's a good question. So how do interviews vary among junior and senior? This will also depend on the company. Some companies will have a different interview loop for someone going into one of these like freshman or sophomore roles, and that the questions might require only like basic data structures and don't require you to know what a heap is or what a red-black tree is or something. Where the more experienced interviews might have those types of questions. Another thing that might differ is the expectation. So we might give the same exact problem to someone who's a freshman and someone who's a junior and just have different expectations of how far they get and solve it. Like we might give a problem to a freshman and not expect at all that they get to a solution or that they get just the naive solution. We're giving that same problem to someone who's a junior. You might expect them to get the optimized solution and know what caching and memoization is and things like that. So I think those are the two ways it could go. Other questions? Oh, sorry.
How disadvantages someone if their degree doesn't say CS on it?
My degree is actually in organismic and evolutionary biology. And so it's basically the same bar. I had to go through the same interviews as Tommy, who actually had a CS degree. I did well enough to get a job. He did well enough to get a job at Quora. But yeah, I guess it might, perhaps for some companies at least, will make it harder to get an interview in that people might think you'd have no experience while you're applying for this. But at least at Quora, once you're at the interview, we don't really care what your degree is in. We care how well you do in interviews.
Yeah, that's definitely true. Like someone might have a degree in government or something, but if they have 3 tech internships, it's clear that they're looking for engineering. That's totally fine. The harder one might be if you're pursuing a degree in government, you don't have any internship experience yet. That's a little harder, but that's where these side projects and showcasing things you've built can help make it clear to people that this is what you're looking for and that you're capable. Yes.
How much higher? So if you don't have a CS degree, how much higher is your bar then for your side projects or your personal ones?
Yeah. So if you don't have a CS degree, how does the bar change for projects? I think it's more about less concerned about what the degree is and more concerned about what your experience is. So as an example, someone who has you take the exact same person, they worked at the same 3 internships so the past 3 summers, but one has a degree in CS and one doesn't. I think those are basically identical resumes. So I think it's more about what you've done and less about what the text on your degree is. Because you can also take 18 CS classes but get a degree in something else. I don't know why you do that, but some people do. Yes?
So you mentioned how knowing kind of one language well or 1 or 2 is generally okay. What about in the case that you're given existing code in an interview? Is that reasonably you can see it in different languages or?
Yes, that's a good question. So with this practical interview, it is obviously written in some existing language. How do you handle that? So in Quora's case and other companies as well, we'll ask you in advance. We'll say, hey, you're going to have a practical interview. Your choices are Python, Java, Swift, or C++. Those are Quora's choices. So we'll just ask you in advance, and then you pick one of those. If you don't know any of those languages, which happens, some people don't know any of those 4, that's okay. You could just say that, hey, I don't know any of these languages. This is the closest one to a language that I am familiar with. And just say that to your interviewer up front. Often you can read syntax. You can read Java syntax if you're familiar with C, and that's okay. But you might not write perfect when you write the code. It might not be perfect. That's okay. Just vocalize it to your interviewer up front. But more often than not, you will have some amount of choice so that you're not forced into, here's a 10,000-line Haskell code base, go. I think we have time for one more question. Yeah.
Okay, so you talked a lot about people knowing the code, being able to demonstrate that. You talked a lot about being able to communicate and work with your interviewer. You've also alluded a little bit when you look at resumes and stuff about passion of what. Can you say a little bit more about that? I know I tell students often that this is going to be important at all stages of your career, but how do people get that across?
Yeah. So basically, how do you get across some passion for the field? I think one way this really comes across is in these culture interviews where I'll ask somebody, what are you looking for? Why do you want to work here? And some people, in Quora's case specifically, our mission is all about sharing and growing knowledge. And some people come to me and they say, I just love your mission. It's so important to the world that this knowledge exists and that it's accessible to everyone. And I just, I come from this background and I'm really interested in online education and all these other things. And that just demonstrates to me you're really excited about our mission and our product. And some of these people have never even used Quora. They've just, they said, oh, I know this is your mission and I've been on the product a couple times. I'm not an expert on it, but I know this is your mission and I'm so excited about that I want to contribute to your product. That to me shows that you're really excited to work for this mission. Other people I say, why do you want to work at Quora? They say, I don't know, I heard smart people work here, which is a really common answer. Or just, I don't know, I like Mountain View sounds cool. And that to me shows that you're not passionate about the product or the mission and that you're sort of missing that piece. And the reality is at a lot of these companies, you're going to be surrounded by people who are extremely passionate about the mission and about the product. And so if you aren't, that's just sort of, it's going to be this weird fit on both sides. So I think that's the most common way. In these conversations, everyone's going to be interested of why you're applying to us. And the more that you can demonstrate why you're passionate about the problems we're solving, that's how you can sort of communicate that to people.